All right, hi guys, welcome back. This is Module 56, and we're going to be talking about human disease. So, our learning objectives, we need to identify the different types of human diseases, understand risk factors for human chronic diseases, discuss historically important human diseases, identify major emergent infectious diseases, and discuss future challenges for improving human health. Okay, so different types of human diseases. So first we need to differentiate between a disease and an infectious disease versus an acute disease and a chronic disease. So a disease in itself is anything that impairs the function of the body with a characteristic set of symptoms. So you're probably familiar with this. An infectious disease is something that's caused in particular by a pathogen. A pathogen can be many things. It can be a virus, it can be a bacteria, it can be a prion. But an example of that would be pneumonia, STD, HIV. Those are all infectious diseases, and we'll talk about those a little bit more. And then an acute disease is something that impairs your body's function incredibly rapidly. As soon as you get this disease, it is a quick turnover. So something like Ebola, where the fatality rate is 90%, and within 2 weeks of contracting this acute disease, you're dead. Whereas with an infectious pathogen, it would be something that takes much longer and doesn't necessarily kill you right away. And then a chronic disease is something that it's the opposite of acute. It will slowly impair your body and kill you. So something like cancer or heart disease isn't going to happen overnight. It could be years, decades of that disease before you actually see the fatal symptoms. Okay, so let's take a look at leading causes of death in the world. So of course you guys probably already know this, but one of the largest categories is cardiovascular disease, so heart disease. And this is not just in the United States, this is all over the world. Respiratory and digestive diseases, various cancers, and cardiovascular diseases are sort of the biggest thing here. So the reason that respiratory and digestive diseases are so high is really because in developing countries where there's not access to clean water, it ends up being a bad gut pathogen that causes extreme diarrhea or consistent diarrhea, which then leads to dehydration and malnutrition. So it's those digestive diseases that can oftentimes lead to death as well. And you're all sort of familiar with cancer. And then of all of the world's deaths caused by infectious disease, here's infectious disease in this 15% category. 94% are caused by only 6 types of diseases. And here are those big ones. So respiratory infections. So we know how respiratory irritants work and why there are so many of them because we had an air pollution unit. HIV/AIDS is a pretty big one. And then those diarrheal diseases, and TB is, of course, a respiratory type 1. Malaria, we know the prevalence of malaria. We'll talk about that more. Okay. So a lot of things contribute. Numerous risk factors exist for chronic risk. That's a crazy sentence. Sorry, I didn't realize that. Okay. So in low-income countries, the top risk factors including leading to chronic disease are associated with poverty. So we know that in lower socioeconomic statuses, the types of diseases that affect people are what we would consider more of a mainstream type disease, whereas the risk factors for high-income countries become a much more complicated type of disease. So we sort of already touched on this, but with poverty, oftentimes comes unsafe drinking water, poor sanitation, and malnutrition. So people in lower socioeconomic status sometimes can't even afford to feed themselves. So the diseases that they're suffering from come from things that come from not having the immune system built up from being poorly nourished, not having access to clean water. That's where those digestive conditions come, or being exposed to those lung irritants like either burning wood inside for a source of heat or for cooking, right? So all of those are going to lead to very simple diseases that could easily be taken care of if you weren't living under those conditions. Whereas the risk factors change as you go into a higher income country. Then you start to see you have an overabundance of things, and as a result, you're going to lead to a different type of poor nutrition. So things like overeating and obesity and heart disease and blood pressure, increased availability of tobacco, things like that. So because it's almost gluttonous, right? It's the exact opposite. You have too much of something. And that has its own set of problems that are associated with it. Okay, so here are the risk factors, just looking at a chart in low-income nations versus high income. So you'll notice in high income, those are the pink bars, it's blood pressure and tobacco use that lead to the most, or these are the highest risk factors, and of course both of those are going to lead to things like heart disease. And then in low-income nation, we've got things like childhood malnutrition, unsafe drinking water, high blood pressure. Again, all of that is going to be related to poor nutrition and poor sanitation, and potential air pollution. Okay, so we're also going to look at some diseases that have been very historically important, and that's what we care about in this class. We're curious about pathogens such as fungi, bacteria, and viruses that have caused major sort of epidemics in human history as a result of an environmental cause. So whether that's from wild animals, from drinking water, from air, from livestock, other humans, those are the ones that we care about the most. So that's what we're going to be focusing on. So for infectious disease, you can have either an epidemic or a pandemic. So this is very relevant to right now. Pandemic is what we're currently in, an epidemic that occurs over a large geographic region. So the interesting thing about the term pandemic, it's become very widely used, but really the flu virus every year is a pandemic. It occurs over a large geographic region. It spreads very rapidly. So technically we kind of are in a pandemic pretty much all the time with the flu season. An epidemic is a situation in which a pathogen causes a rapid increase in disease. So something like Ebola, the Ebola epidemic would have been something you could categorize as an epidemic. Okay, so we're going to look at some examples from history. So this one is probably the one you're most familiar with because you talk about it in your history classes when you talk about the bubonic plague or the Black Death, which is also, this is sort of all in the same category here. This one is caused by a bacteria, and it's usually a bacteria that is carried by fleas. Now, what happens is these fleas attach themselves to rodents like rats or mice, which allows them to have increased mobility, and then people who are interacting with rodents like rat or mice are at an increased, have an increased chance of getting bitten by those fleas. Fleas feed on mammals, things like cats, dogs, humans. And then as soon as you're bitten by an infected flea that's carrying this bacterium, or you're living in close proximity to these rodents, you'll start to develop symptoms of the plague. Swollen glands, black spots on your skin, extreme pain, and throughout history we've seen this kill millions of people. Now, we still occasionally we'll see breakouts today, but remember this is a bacterium. So we actually do have antibiotics that are used to treat this. At the time when the Black Plague or the Black Death or the bubonic plague were really prevalent, antibiotics weren't a thing, so it was just mass killings of people. But now we have antibiotics and we don't see that widespreadness of this particular disease. Malaria, probably another one you're familiar with. This one is not a bacteria, it's a protist. This is also one that has been widespread and has killed millions of people over time. It's predominantly found in places like Africa, Asia, and the Middle East. Those are the places that tend to be hit hardest due to the tropical sort of warm nature of their ecosystems that sort of promote the rapid abundance of mosquitoes. We actually don't have this problem here in the United States. We don't have malaria here in the United States because we have a pretty controlled mosquito population, which is why we don't tend to see it here as much. We do have cases of malaria in the United States, but they come from people who have traveled to regions where malaria is present. Now, there's really two life cycles to malaria. The first half is in the carrier, the mosquito, and then the second half lives in you, the human. And you basically get flu-like symptoms. So sometimes it's hard to differentiate. A lot of people die from this each year. 1 million people die from malaria every single year. The main way that they started to control malaria, or what they used to do, was mass spraying of DDT to control the mosquito population. So really that's the only way they could figure out how to control this problem, was to control how many mosquitoes people were interacting with. Of course, they don't use DDT anymore, so it's still the focus is on eliminating the mosquito populations and decreasing the numbers. Okay, tuberculosis or TB. This is something that if you're a school teacher, or I don't think they do it at Sage, but public schools require students to get TB tests every single school year. So I think I've had a TB test. I had one when I got hired for Sage. I've had a lot. They, if you've ever had one done, they give you an injection in your arm, in your forearm, and you come back 2 days later to see it, to have it red is what they call it. And if your skin has like bubbled up, that means you're positive for the TB infection. And they don't want people, especially like school teachers or educators or students, because you're exposed to large groups of people every day, which is why schools are very adamant about you getting tested before you're involved with everybody. It's highly, highly, highly contagious. It is bacterial, but it's highly contagious. And it's spread sort of similarly, in a similar way that the coronavirus spreads. If you cough and those droplets get into the air, those droplets can survive for several, those bacteria in the droplets can survive for several hours. And if you inhale them as a healthy person, those bacteria will end up in your lungs and you will get tuberculosis. So you have this weak feeling, you have sweating at night, you're coughing up blood. It's an interesting disease because you can actually test positive for TB and just be a carrier of it and display no symptoms of it. This actually happened to a friend of mine. She was a swim instructor and she was working with little kids, and a kid sort of coughed in her face. And she developed really, really mild symptoms, so she went to the doctor and they tested her for TB, and she had TB. And so what she ended up having to do was take antibiotics for a year. So you're on these antibiotics for an entire year, and they have really strange side effects. There's actually a lot of foods you can't eat because they interact very negatively with people. But after a full course of antibiotics, you should be good to go. But a year is a long time for antibiotics. What they're also finding is that in countries where TB is really prevalent, they're starting to find drug-resistant strains of it. TB will kill you over time if you don't treat it. So if you take your course of antibiotics for that year, you'll be fine. But if you let it go untreated, or you have an antibiotic-resistant strain that they can't figure out an antibiotic for, then it's possible for you to die. Okay, so this is looking at the number of tuberculosis cases that we've had since the 50s, and then the number of deaths. So you see that the number of cases have decreased significantly, and this is really due to the availability of antibiotics to treat it. And then here in the United States, and then you'll notice that the deaths have decreased rapidly. You'll notice, though, that the amount of tuberculosis cases worldwide really has not decreased, and the deaths have decreased slightly, but they're still almost pretty level. And again, this really has to do with access to medicines. People in poverty-ridden places, which is oftentimes where tuberculosis is prevalent, don't have the money to pay for those drugs that will treat the tuberculosis, or you'll notice that it's 1 year of antibiotics. If you don't take that full course of antibiotics, a year is a long time to commit to, then you potentially risk developing an antibiotic-resistant strain and not allowing yourself to heal from that. So these emergent infectious diseases pose new risks to humans. So an emergent infectious disease is basically something that hasn't been seen ever before, or hasn't been prevalent in a really, really long time. And so as a result, humans haven't built up any type of like resistance, and we have no research to support it. So emergent infectious diseases can be more deadly. And what are we dealing with now? This COVID-19, right? A type of coronavirus that is what we consider a new emergent infectious disease, and we're seeing sort of these new risks because we have no vaccines for this. We have no research done on it, and so we're sort of trying to fly the plane as we're building it here. So these are the ones that pose the largest risk, and that's sort of what you're seeing right now. So we'll look at a couple examples of this. So the first one is HIV or AIDS. So HIV is the virus, the human immunodeficiency virus is the virus that you contract, and AIDS is the disease that you get after having HIV for a long period of time. Now, it's an immune disorder disease, so it attacks your white blood cells. You get it through coming in contact with or coming into sexual contact with somebody, through blood transfusions. Probably not so much anymore. Blood transfusions are pretty heavily monitored, but at some point they weren't. Anyone could donate blood, and that blood could go to somebody. From mothers to their fetuses, and shared needles, so like a dirty needle, essentially. So you never want to come into contact with anybody else's blood, or through sexual contact or anything like that. That's something that you really want to be aware of. So where do they think that this disease came from? They believe that it came from a group of wild primates or chimps, and that it was actually spread to humans because they were killing and butchering them as for food, as a source of food, which is pretty common in like places like Cameroon, things like that, to eat primates. But as they were coming into contact with them, butchering them and eating them, they were exposed to the HIV virus, and then it just began to spread rapidly. Now, there are antiviral drugs that can help maintain low HIV populations inside the human body, which will lessen your chance of ever getting full-blown AIDS and expand or greaten the length of time of your lifespan. But really, there's no way to get rid of this. And we know that we've seen throughout history major outbreaks of HIV and AIDS just from simply not knowing, right? So we could talk about this in quite a bit of detail, sort of the history and the sort of the late 70s and 80s, sort of the craze that went on as people sort of found out about this, and the misconceptions about who got AIDS and who got HIV, and kind of how we got those numbers down so quickly by simply educating people. And like, hey, you can't do that. Doing that will give you some sort of disease you can't get rid of. Okay, Ebola, everybody's favorite. Ebola hemorrhagic disease, or fever. And you probably know all about Ebola because everybody likes to talk about Ebola. Has an incredibly high death rate. 90% of people die from this. It was first discovered in the Democratic Republic of the Congo near the Ebola River. So the Ebola virus was named after where it was found in the Ebola River. But it gives you symptoms like fever, vomiting, and then internal and external bleeding. So you basically just start bleeding out of your orifices, and your fever is so high that your body is shutting down. The only treatment they have is symptomatic, so try to treat the fever, try to treat the internal bleeding. But for the most part, within 2 weeks, people are usually dead. They believe that this was carried by fruit bats. This one we haven't seen it widespread throughout the world. We've seen it in very specific locations like Burkina Faso, right? That was the 2014 outbreak. And it can be contained because it's spread throughout people very quickly. So if you can contain the people who have it, then you're not going to see this mass widespreadness of it because symptoms are so prevalent. They're so quickly onset and so prevalent. Unlike this coronavirus that we saw, this COVID-19, you saw massive spread of it because people don't know they have it, right? It's going, and you're getting on planes and you're getting on trains. With Ebola, the symptoms are onset so quickly, and you rapidly deteriorate so much it's easier to contain people. Okay, mad cow disease. This one almost sounds fake, but it's not. So this one has to do with prions, and prions are actually these. There's not a lot understood about them, but they're these misfolded proteins that eventually lead to pathogens. And what happens, particularly in mad cow disease, is these prions, which are in cows' brains, or these proteins that are in cows' brains, get mutated over time, and they'll slowly damage their nervous system. So what you actually end up seeing is this cow who starts to lose its coordination and sort of start panicking, like somebody who's gone mad, as they say, and you end up with mad cow disease, and then they eventually die. And if you look up images of cows that have been infected with mad cow disease, you'll see them sort of totally disconfigured in all these crazy, like weird, like positions in their body, and it's actually very sad. You can probably watch videos. I'm sure PETA has something up, but it's actually pretty crazy. But it's sort of chance. It's proteins, and prions are not well understood, and they're very scary actually. But what happens is if you are a human can contract mad cow disease by eating cow meat that has been infected by these prions. And humans will contract the exact same disease with the exact same symptoms, but the problem is you may not know that you have mad cow disease. You could sit for decades and not know, and then one day it would show up. There's no treatment for it unless you know you've consumed bad cow meat. You would have no reason to go test for it. Actually, when I was training to become a teacher in my master's program, my teacher who I worked with, who was sort of my training teacher, had been exposed to there was a huge outbreak in Europe at some point. They were actually like banned from selling meat. He happened to be in Europe during that time. And at some point he got a letter in the mail saying, you may have been exposed to mad cow disease. But he's never experienced any symptoms, so he sort of lives his life day to day wondering if today's the day he'll start experiencing mad cow disease symptoms. He may not have been exposed at all, but there's the possibility. Okay, swine flu and bird flu. You've probably been familiar with these. H1N1 is swine flu, and then H5N1 is the bird flu. The swine flu one is what the Spanish flu was, and we know how crazy the Spanish flu was. But these are the swine flu and the bird flu mean that these diseases originated in either pigs or birds, and normally you don't actually see them go from pigs to birds to humans, but occasionally they do, and that's when we get the flu symptoms. Rarely will this kill birds or pigs, but in humans it's incredibly harmful, and you are already aware of what flu symptoms are like. That's something that you may get plagued with annually, but that's why we have those flu vaccines, in hopes that we can predict what virus strains will be prevalent that year and try to prevent them. Now that H5N1, that's the avian flu or the bird flu, we don't really have a ton of evolutionary history with this particular flu. So when the bird flu came around, H5N1, we saw a massive amount of people get sick with this flu. And I remember my brother was in middle school and I was in high school, and it was crazy. They had over 50% of the school's populations were out because they were sick. Most people did recover, but you saw much higher than normal death rates from the flu that year than ever before. Okay, SARS and MERS. These are our human coronaviruses. We're here. We're talking about it. So SARS is a severe acute respiratory syndrome. It's similar to a flu. You get symptoms of the pneumonia, which is what they initially said COVID-19 was. But it turns out it's a little bit more than that, right? But it's the pneumonia-like symptoms. And these are all diseases that have originated from animals. And can very rapidly spread from human to human. So SARS was a big one. Again, it's more of a coughing, respiratory pneumonia type thing. And coronas is a respiratory infection, but it's not as severe as pneumonia. The cough is much drier. It's the other symptoms that are making people much sicker. West Nile virus, you've probably heard of this. This is one that is again carried by mosquitoes. Those darn mosquitoes and ticks just keep getting us. There are basically, the West Nile virus lives naturally in a ton of birds. If a mosquito feeds on a bird and then a mosquito feeds on you, it can take the virus that the bird had, the West Nile virus, and then give it to you. Birds that have West Nile virus mostly die. Humans, if they get bit by the mosquito and get infected by it, are going to have inflammation of the brain, and it's usually a very rapid death. Now, we don't have a lot of West Nile cases here in the United States. Usually cases of West Nile are happening in other countries and people are bringing them here. Okay, Lyme disease, again, you're probably familiar with this one, carried by ticks, and more specifically, deer ticks. And these are actually the ticks that we have here in Orange County. These are the ones that you'll see if you go out and about. But Lyme disease, actually, our ticks here don't carry Lyme disease. It's mostly the East Coast that has ticks that carry Lyme disease. They also have deer ticks, but these ticks, especially right now, if you go out on a hike or something like that, those are the ones that you're going to see. So ticks have two life cycle phases. They attach themselves to birds and rodents. That's where they get the Lyme disease. And then the second part of their life, they attach to a mammal, like a deer or a human, and they can transfer the Lyme disease. And that is when they burrow themselves in you, that's when it's transferred. Symptoms include a red bullseye at the attachment site, flu-like symptoms, arthritis, various neurological disorders. Dogs can get it, humans can get it. There are antibiotics that will treat this, but many people who end up with Lyme disease end up with Lyme disease for the symptoms of Lyme disease for their entire life. So even though they don't have it anymore, the symptoms never really go away. And the reason it's called Lyme disease is because it was found first in school children in Lyme, Connecticut, who started displaying all of these symptoms. So it was named after a city in Connecticut. Alrighty, and I believe this is our last disease. This is Zika virus. So you'll recognize this image as neuroencephaly. So that's underdevelopment of the brain. So this is the Zika virus is generally associated with underdeveloped head size in fetuses. If you get bitten by a mosquito that's carrying the Zika virus, you won't necessarily incur any symptoms. You'll have pretty mild symptoms and it'll eventually go away, maybe like a mild flu-like symptoms. But other than that, you'd actually be okay. The risk is if you were carrying a fetus or became pregnant while you had the Zika virus inside of you, that would cause an underdeveloped fetus. So there's two ways you can get it: a mosquito bite and from an infected mosquito, or if you actually have sexual contact with a human who has the Zika virus, it can be spread that way as well. So this is why they were so worried about the Olympics a few years back, because they had a massive outbreak of the Zika virus and there was going to be a ton of people there. There's no treatment for neuroencephaly. It's a lifelong sort of battle. And usually the children don't actually live as long. And the only tactic they really have for getting rid of this is to decrease the mosquito populations, just like we saw with malaria. Okay, and this is sort of the last slide. It's a summary slide here. So human health faces a number of future challenges. So of course, in low-income countries, it's going to be a matter of improving nutrition, cleaner drinking water, proper sanitation, if we ever want to see a decrease in some of those diseases that we're seeing there. And then again, in high-income countries, promoting healthier lifestyle choices by having a balanced diet, decreasing your tobacco or limiting your tobacco use, limiting your food consumption so that you're not mass consuming, more physical activity, things like that. And then education outreach. So for those diseases that can be prevented by not having sexual contact with somebody or proximity issues, always education. And that's what we've seen the biggest thing with this COVID-19 outbreak is educating people on ways to keep themselves safe. So that's always a big one. And then, of course, addressing the growing concern of antibiotic resistance. or pathogens that have evolved to have a resistance. So ensuring that people are taking those full course of antibiotics, and that we're not overusing any one antibiotic too much. Okay, guys, that's all I have for you today. Let me know if you have questions, and we'll talk soon. Thanks, guys.